Okay, in this lesson, we're going to stick again with the topic of solving linear equations, and we're going to do it a different way. So, if you have a system, you can also solve these systems by using inverses. And here's how we're going to do it. So, you've got your system, and we're first going to understand that we can rewrite this with matrices. We took our coefficient matrix right here, and we're going to write it as times xy. Now, why can we do that? If you actually were to multiply that back out, if you multiply a row times column, that'd be a times x plus b times y, which is this. Ax plus by is equal to e. There's your first equation. Your second equation, if you took this row and this column, cx plus dy, which is this, is equal to elf. So therefore, we've just split this into a coefficient matrix times the column matrix there, xy, and then is equal to the column matrix elf. So if A is equal to the coefficient matrix, x equals this and b equals this, then we understand that this system up here is now written as ax equals b. So how can we solve that? Well, think about how can we solve 2 times x equals 6? To get rid of 2, you go to the other side and you multiply by 1/2, or you multiply by the inverse. So keep that in mind, because now what we're going to do is we have this a times x, where a and b are matrices. Well, how can I get rid of that a? We can take both sides and multiply by a inverse. Order does matter, so you do have to be careful here. So we're going to multiply a inverse times a, and we understood, again, that anytime you multiply a matrix times its inverse, you get the identity matrix. And anytime you multiply anything by the identity matrix, you get just that matrix itself. So how do we figure out what our x and y are, which in this case is, again, our x? We do this. Therefore, x and y, which is our column matrix x, will equal A inverse times B. So therefore, to figure out what x and y are, we can actually work it like this: solving systems. Write the system in this form. Find A inverse, then multiply A inverse by your constant matrix B, and you're done. So this right here is all we're doing. So the first step is let's write it like our system up there. So you have your coefficient matrix 7, 5, -6, 1 times xy will equal your constant matrix -14, -25. So here is my matrix A. So now let's find A inverse. And if you can't remember how to find A inverse, here is the steps. I'm going to write it over here. So you do 1 over the determinant, and then you multiply that by this matrix. You flip-flop your A and D, and you make the other two negative. So therefore, the inverse here, we're going to do 1 over the determinant. The determinant down minus up is 7 minus -30. That's 7 plus 30, which is 37. Now we take and flip-flop these two. That's going to be a 1 here and a 7 here. We make the other two negative, so a +6 and a -5. So therefore, our inverse is going to be this matrix: 1 over 37, -5 over 37, 6 over 37, and 7 over 37. So there's A inverse. So what do we do? To move A over here, again, we're simply going to multiply by our inverse. So we're going to take that inverse, and we're going to multiply it times our constant matrix, -14, -25, and whatever we get as an answer, that's going to be our solution. So we multiply row times columns. The first row times the only column is going to be -14 over 37 plus a negative times a negative is going to be a positive, and you've got, 125 over 37. And whenever you calculate that, that's going to be 121 over 37, or excuse me, 111 over 37, which is 3. Second row now. Second row times the only column will give you a -84 over 37 and a -175 over 37. When you combine those, that's a -259 over 37, which is 7. So therefore, x is 3 and y is negative 7. Second example. Again, matrix A is going to be your coefficient matrix 12, 11, negative 8, and negative 5. And I'm going to go ahead and I'm going to find A inverse. The way that you find A inverse is you do 1 over the determinant. The determinant is down minus up. That's going to be negative 60 minus negative 88, which will be negative 60 plus 88, which is 28. And then times, we flip-flop these two. That's going to be a negative 5 here and a 12 here. Make the other two negative. That's a positive 8 and a negative 11. So therefore, your inverse is going to be negative 5 over 28. 8 over 28, which is, let's see, that's going to be 2 over 7. Negative 11 over 28. And 12 over 28, which is 3 out of 7. So there's A inverse. So now all you have to do is take that matrix and simply multiply it by your constant matrix, and you are finished. So negative 5 over 28, negative 11 over 28, 2 sevenths and 3 sevenths, times your constant matrix, which is negative 35, 21. Okay, so here we go. We're going to multiply row by column. And I'm going to write these down because these are a little bit trickier. I've got to do negative 5 over 28 times negative 35. Then I got to do plus negative 11 over 28 times 21. I can cross cancel there. 28 and 35 gives me a 4 and a 5. 28 and 21 gives me a 3 and a 4. So that's going to be a positive 25 over 4 and a negative 33 over 4, which is negative 8 over 4, which is negative 2. For the second row, I've got to do 2 sevenths times negative 35. Then I'm going to add 3 sevenths times 21. Again, cross cancel. 7 and 35 gives me a 1 and a 5. I'm going to go ahead and put that negative back out front there. 7 and 21 gives me a 1 and a 3. So this is going to be negative 10, and this is going to be a positive 9, which gives you a negative 1. So therefore, x is negative 2, y is negative 1. Example number 3. Again, matrix A. Our coefficient matrix is 6853. So therefore, A inverse is going to be 1 over the determinant, which is 18 minus 40, which is negative 22, times, flip-flop the 3 and 6, make the other two negative. And that gives us A inverse, which is negative 3 over 22. A positive 5 over 22 goes here. Negative or positive 8 over 22, which would be 4 elevenths when you reduce it. And then negative 6 over 22, which is negative 3 elevenths. So there is A inverse. So to find your answers, you're going to take that inverse. Let me copy it down again. Negative 3 over 22, 4 elevenths, 5 over 22, and negative 3 elevenths. And we're going to multiply it times our constants, negative 16 and negative 28. And again, I'm going to come over here to the side to do that. Row by column, we're going to do negative 3 over 22 times negative 16. Then we're going to do plus 4 over 11 times negative 28. We can cross cancel here and here. That's going to give me an 11 and an 8. Here, well, we can't cross cancel anything over there. So I have now on top a positive 24 over 11. And over here I have a negative 28 times 4 is 112 over 11. When you subtract those two, you get negative 88 over 11, which is negative 8. Now let's move on to our second row. You have 5 over 22 times negative 16 plus negative 3 over 11 times negative 28. Cross cancel here and here. That's going to be 8 and 11. 5 times negative 8 is a negative 40 over 11. 3 times 28 will be a positive 84 over 11. When you combine those, that gives you 44 over 11, which gives you 4. So therefore, your final answer is negative 8, comma 4. Okay, number 4, we're actually now moving on to a 3 by 3. You have X, Y's, and Z, so a little bit different. However, the process is going to be the same. Matrix A is going to be the matrix 2, 1, negative 1, 3, 4, negative 2, and 1, 6, negative 3. Whenever you find the inverse of that, you're going to get A inverse is equal to 0, 3 sevenths, negative 2 sevenths, negative 1, 5 sevenths, negative 1 seventh, negative 2, 11 sevenths, and negative 5 sevenths. Now, all you have to do to find your final answer is take that inverse matrix. I'm just going to put it as A inverse instead of having to rewrite it again. And you multiply it by your constant matrix, negative 16, negative 23, negative 17. And when you do, you get for a final answer negative 5, 2, and 8. And that will be your solution. Order triple, negative 5, 2, 8. There's the point where these three intersect. Example number 5, the exact same thing. Take your coefficient matrix, A, we'll call it, which is going to be this. We are now going to find the inverse of our coefficient matrix, and you're going to get. Next up, we're going to take that inverse matrix. I'm not going to copy it down again. You're going to multiply it by your constant matrix, which is negative 4, 27, negative 5. And when you do, that's going to give you your solution, which is 1, negative 9, and negative 2. And that's your X, Y, and Z. Okay, last example here, example number 6. Again, just going to go through the process, not actually going to do it for you. We're going to take our coefficient matrix A, which is just taking your X, Y's, and Z coefficients, which is this. Next up, you will find the inverse of that matrix, A inverse, and that's going to equal the following matrix. And then once you find that inverse matrix, again, you simply take it, multiply it by your constant matrix, 8, negative 29, 53, and once you do that, you're going to get the matrix here, 4, negative 3, 3, which is going to be your answer. X is 4, Y is negative 3, and Z is 3.